Okay. Karibu tena kwenye kipindi chetu cha fizikia. Tunamalizia swali namba 3. Swali namba 3. Tutana nami Mama Physics kwenye mada the theory na practicals physics, hasa kwa kidato cha 5 na cha 6. Wasiliana nami kupitia WhatsApp namba 0712579612 ama YouTube channel yangu Mwashamba Magulumali. Okay. Swali letu lilikuwa nataka tuchore grafu kwanza. Tumechora graph yetu ni kama inavyoonekana hapa. Kwamba labda utaniuliza kwa nini nimetumia solid line kote wakati data zangu zilikuwa concentrated at the center. Kwa hiyo kama tulivyosema kwamba kuonyesha extrapolation ama interpolation of the line, kwamba itategemea huko kwenye quadrant ya ngapi, kwamba data zangu zipo kwenye quadrant ya kwanza na sijavuka kwenye quadrant nyingine. Kwa hiyo sitakiwi kuweka dotted line huku ama kuweka dotted line huku, kwamba ninahitaji y intercept, ninahitaji x intercept, lakini nitatumia solid line because kwamba data zote zilizopo hapa manake zimo ndani ya experiment yangu. Okay. Kwa hiyo tunakwenda kujibu maswali yetu. Baada ya kuchora graph, B was to plot a graph of t squared against d in centimeter. Determine the slope of the graph. Slope of the graph. So slope of a graph can be determined by taking the change in t squared dividing by the change in d. Slope. This is the change in t squared dividing by the change in d. So change in t squared in this way, we have 3.95 here. So 3.95 minus the lowest point here, it is 1 dividing by this one minus this one. So this one, it is a 40, this is the centimeter, minus at this point, if you can read it correctly, this is the 110. Each division takes 1, so this is 110. There's another 4 centimeters here, another 4 centimeters at here. So here it is 114. So this, if we take the difference here, it is 2.95 divided by negative 74. So the ratio of it gives us negative 0.0399. Remember, this is measured in seconds squared, this is in a centimeter. So this is second squared dividing by centimeter. So a slope, therefore a slope could be is equal to this one. This is the slope of a graph. Or you can approximate it into 2 decimal places. It can be equal to 0.04 second squared per centimeter. Okay. Question Roman 2. Determine the intercept along d-axis. Determine the intercept along d-axis. So the intercept along d-axis, determine the intercept along d-axis. Here, along d-axis, the intercept here, it is 140. So d-axis intercept is 140 centimeter. 140 centimeter. Again, Roman 3. What does the intercept along d-axis in Roman 2 above represent? D-intercept, tukija kwenye mchoro wetu, D-intercept inatuonyesha kwamba the height from the ground to the point of suspension. To the height from the ground to the point of suspension. kwa sababu pale original tulipewa hii distance tuanzie 100. Distance from the ground to the bulb it is 100. Then tukaendelea kuvary distance. So the remaining distance, the remaining distance is x. So x plus this d, it could be the value of h. So it is 140 centimeter is the height from the ground, h. This is the height from the ground. From the ground to the suspension point. Okay. What did that then? Okay. Roman 4. If t squared is equal to negative 4 pi squared d over g plus 4 pi squared h over g is the equation for the motion of the pendulum. Calculate the acceleration due to gravity of the pendulum. So if we have given this equation, means that let we compare. The equation is t squared is equal to negative 4 pi squared d over g plus 4 pi squared h over g. We have a slope from the graph. From the graph, slope is equal to negative 0.0399. This is centimeter squared per second squared per centimeter. So if we can compare slope from a graph and the slope from the equation, we shall have the g, the value of g. So here we have negative pi squared, 4 pi squared dividing by g is equal to negative 0.0399. Making g a subject here, negative and negative cancel out. G a subject, it could be 4 pi squared dividing by 0.0399. This gives us this is 39.4384 dividing by 0.0399, which makes us to have 988.43. This in terms of second squared per centimeter. So if we make g in meter per second squared, g in meter per second squared, g in meter per second squared means divide this one by 100 or multiply by 10 per negative 2. So here it is 9.88 meter per second squared. So this could be the value of g. The aim was to determine the acceleration due to gravity. Determine the acceleration due to gravity, and the acceleration due to gravity here we have 9.88. Otherwise, mwingine angeweza ku approximate to one decimal place. To one decimal place ungeweza kupata 985. To one decimal place ungepata 0.04. Ukigawanya hapo ungepata 985.96. This is second squared per centimeter. Or otherwise ungepata 9.86 meter per second squared. Okay, so as we have said that g varies from 9.80 to 10. Tunachukulia mara nyingi tunapewaga 9.8 or 10 kwa sababu wanasema kwamba error of simple pendulum is plus or minus 0.2, but error can always be maximized. Error always be maximized. So that's why whether tunapewa 10 ama 9.8. But experimentally you can have whether it is 9.6 to 10. Okay. Thank you. Until next time. Usisahau kusubscribe ama kuweka alama ya dole gumba kama umependa video hii. Asante.